It's probably here designed for this specific scenario. In general, if every team is doing one thing, like 2, 3, 4, just go with whatever.
But you actually want to look at it. And then
Yeah, but this one's almost broken.
See that?
Do you have any questions about?
Do you guys like regularly use smartboard?
Yes.
What advantages do you gain by it?
Well, actually, I'm going to cover that in my presentation. So, one of the why you should use pneumatics is that let's say you're looking at elevators, right? So you guys have elevating the passageways.
Yeah.
Oh, I'm sorry.
I was like,
No, just mostly just like the gyro in it is pretty good, and then basically most boards when you have the gyro in it, a lot of the
what I did last year is
plugging points, and then with this one, I think reminds you how. So this gets air from outside inside here, right? Yeah, this is to show how much air is in here, and then, but still it's going to go here, it's going to be here, it's going to go here, and then it's going to.
You have that one, right?
Set this up.
That one's attached.
The fire station.
Yeah, that one.
You have basically
It's going to be
somewhere
attached
going into
So then you're going to use the shaft to
like without this, and you're
I guess doing a lot of things at the same time.
after this, oh, it's like you're running a risk of like you're really like drilling the sensor, like not either. Yeah, because it's like it's cutting out some pads where like it's not reading correctly or resetting. Tell me what that pneumatic do. It shoots a pistol. Make it high five.
How would you using your robot? Your robot's in the center, right? So,
That's why. No. I remember there was a problem that ultimatum problem is that we had a different gyro that was plugged into right so we had this issue, and then basically what we had to do is set the gyro and then spin because there was parts of it dependent on the gyro, and the gyro was like I don't know where I am, but I have to angle that, so I'm gonna just keep turning. You see that computer? Oh, yeah. Okay.
With that much machine capability, it'll be a lot easier to the actual.
Okay. I will contribute. Do this. Oh man, I don't get a hot computer. What? Are you gonna introduce going on pneumatics? We'll let Hector and Peter take control.
All right. Awesome. So hi, I guess we'll start by introducing ourselves. My name is Hector. I'm a mentor for the Neutrons. This is my second year mentoring. I'm currently a sophomore at MIT over across the river. I'm studying mechanical engineering with a concentration in robotics. And this is,
Hi, my name is Peter. I mainly go by my nickname, Double Click. So this is my 4th year on the team. I'm a part of a mechanical subgroup, and I go to Boston Latin School. I'm about to graduate, really happy and excited about that. Yeah, and today we'll be talking about pneumatics.
oh, another thing I forgot to mention, I am a first alum, so FRC, I did that in high school, so this is part of why I'm here. All right, so.
Your arrow keys don't work.
All right, so we want to start off by talking about what is a pneumatic system, right? So basically, a pneumatic system is a system that basically converts compressed air into linear mechanical energy, right? And so there are 3 major components in a pneumatic system, just like in the rough overview. So you have your storage of your compressed air, your solenoids, which basically switch between which channels you want your air to flow, and then your actuators, which are actually doing the mechanical movements.
Also, there's you can also consider it as 2 parts. Upstream, meaning that it's going to store the air inside the actual air tanks, and working, which means that the air is going to go to the components, and the component is going to have power to, like for example, a cylinder is going to extend in a linear motion.
Yeah, and we'll get into the details about the different regulations between stored versus working. So here's just a rough overview of the whole system layout. So you basically start up here with your compressor. This is what creates your compressed air, right? You have your pressure relief valve. There's a number of different safety measures in place, such as the pressure switch, your pressure vent plug, your stored pressure gauge, so you know how much pressure you have in the stored part of your system, your air tank to hold all of that compressed air. And then down here, like Double Click said, is the working portion of the system, where you have your working pressure gauge, which brings down your stored pressure to a regulated PSI, and then you can use that to send to your actuators to perform whatever mechanical movements you want. All right, so I wanted to throw in some examples just so you can kind of get a good idea of, what kinds of mechanisms pneumatics are used for. So this is actually the robot from my high school that I built in 2016, where we use pneumatics to actuate the shooter hood and to bring down the intake. And then I just created this GIF a while ago, and I thought it'd be cool to put in. And so this is escape velocity. This is a 125's robot from 2016 also. And so they use pneumatics for their catapult mechanism, which they use to launch the ball into the tower. And finally, we have 254 who use pneumatics to power their climber to be able to climb the big pyramid in 2013.
Also, can I say something? So I'm going to quote one of our alumni from our team, Jeremy Noel. He said that what separates the big boys and the little kids from FRC is that they know how to use pneumatics, and that they actually optimize for pneumatics.
Yep. All right, so here's a big system overview again, where we kind of lay out the list of the different subsystems within the whole pneumatic system. So we start with a compressor. We're going to move down to high pressure storage, safety and stored pressure gauge, your working pressure regulators and gauges, and then your solenoids, cylinders, and your electronics. All right, you want to start with compressor?
Yep. So the first things first. So compressor. This is where you'll get your air. It's going to take in air from outside, put it in your system, and so as it intakes air, the air pressure increases to your desired amount. So the thing about this is that it can be on the robot, like for example the system, or it can be off the robot. Actually, 2 years ago I built a system that could actually charge the robot's tanks outside the robot, and I did have a lot of experience working with it. Also, it needs to meet some desired specs. So it has to be 12 volts, and it also has to be 1.10 CFM.
Yep. and that's the flow rate, which you should be able to look up on whatever design specifications are that come with the compressor. This is the one I believe that comes in the kit of parts right now. This is a Air, I think I'm saying that right, compressor. It's really nice, really small and compact, a lot lighter and smaller than the ones that they used to give us. And yeah, so a word on the off-board versus on-board compressor. So pros for having an on-board compressor are you can basically keep like replenishing your compressed air throughout the entire match, right? Let's say you have a system that is going to be firing like, you know, all the time during your match, and you don't have enough, you wouldn't have enough, or you wouldn't have the ability to store all of that air that you're going to need for the whole match. So you're going to need to be running a compressor throughout the match to basically, you know, keep your tanks full. The cons to having a compressor on board is it is heavy. It does draw a lot of current and power, and so it can sometimes put in like a really extra heavy load in your system. And so generally, if you can avoid having a compressor on your robot, that's pretty ideal. And so if you go that route, you would have it off board, and you would bring it over on some platform to your robot to basically like recharge the tanks before a match. And you would have enough tanks, like here we have 3. You'd have to figure out how many tanks of air you're going to need to last you the whole match, basically. So yeah, just a couple of comparisons between the two choices. Yeah, and so on that topic of storage, you want, so the stored pressure, basically, like DoubleClick said earlier, it's the pressure that's upstream of your working regulators, right? So that's going to be generally at 120 psi, and that is regulated by the pressure switch, which I'll talk about in a sec. But yeah, so basically you want to figure out the volume of these, and I think they tell you somewhere, I think wherever you're going to buy your tanks, they'll tell you the volume, and you can calculate, like, let's say I need to calculate this certain or I need this certain actuator to fire X amount of times throughout a match. How much volume of air am I going to go through in a match? You can figure out how much you need, and then figure out how many tanks you're going to need accordingly. And yeah, you want them to be rated for 125 psi burst pressure, which works because these are capped at 120 psi.
Okay, I got this. So, as Hector said before, part of a pneumatic system is that it should have a safety function, right? So right down here, you guys can see that after the air storage tank, that there's a system right here, and that's where safety happens, right? So as you can see in the diagram, there's about there's a pressure vent plug, right? So that's where you can manually switch it, where it can like output air if it does exceed the limit. Or you guys can have a blow-off valve, which is going to pop on its own if it does exceed the pressure.
Yeah, so these actually, all these components are actually required for your pneumatic system, basically as just different safety measures. So this is the blow-off valve right here. It's kind of hard to see because it's tilted down. But basically, this will kind of pop off at some high pressure. Like, let's say your pressure switch fails, this will basically like pop off and keep your compressor from blowing up, basically. And this pressure switch is it's wired up to your pneumatic control module, and once it reads 120, it kills your compressor. So that's what's keeping your pressure at 120 psi. And then, like DoubleClick said, you have your manual valve in case you ever need to release your air to do anything. Cool. All right, so working pressure. So this gauge right here is it's the kind of transition between the stored pressure and the working pressure. So this regulator is used to bring the PSI from 120 down to a maximum of 60. So your working pressure cannot exceed 60 PSI. You don't have to use 60 PSI, you can use lower. Generally you want to use, I guess, like only maybe like a little bit more than like the minimum that you need, right? You don't want to go overboard. But basically, then you have a gauge here to tell you exactly what that pressure is, and then it has this neat little like knob here where you can twist it and regulate the pressure that way, and it just pops back in.
Yep. So solenoids at the end of the pneumatic system. Solenoids are these electronically controlled pieces where it's like the last step of where the air can go through. So if it's on, it activates and it allows the air to go through into the components. If not, it just closes and the air stays still. Pressure remains the same. The component won't work. Also, manifolds, right? Manifolds are mounts for solenoids where they can go on. I think it's here, right?
Yeah.
Yeah. So we have one right here. It's where we can mount the solenoid, so you guys don't have to zip tie it or anything. You can just stick it on, and it'll work, hopefully.
Yeah, and just a couple things to add on. So you could think of a solenoid as a switch, basically, right? So you have these two wires hooked up here to, and this is a double solenoid. You have the wires hooked up to your pneumatic control module, and then you could choose which side to basically turn off and on, right? So as you can see, there are two tubes coming out here. And we'll get into how cylinders work in a second. But basically, this solenoid, given an electrical signal, can decide if you want air to go up like the black tube or up the red tube, right? So it diverts between the two. All right, so cylinders. So this is the cylinder that we have set up right here. Oh, there's pressure in the system, so I can't pull it out. But we'll actuate it in a second. So yeah, it's basically just a piston. And as you can see, the animated GIF over here kind of shows you the inner workings of the cylinder. So you basically have down here at the bottom, let's say you want to extend your cylinder, you would put high pressure air through this hole down here, and then it would push this whole part of the cylinder up, right? And basically all the air that was up here in the top chamber gets forced out of this top hole up here. And let's say you want to bring it back down, then you force air into the top, and then it pushes this whole section down. And you can see that on here. This is the bottom input, and this is the top input right here. And so you can use cylinders for like changing angles of. I think you saw earlier there was like that shooter hood that was you were changing the angle of. You could use it to drop down your intake or something like that. They're pretty versatile, and you can use them for a lot of different things. You can also use them. They make these really small ones that plug into a lot of gearboxes, and you use them to switch between like high and low gear. Those are also really useful.
All right, so how to effectively use pneumatics. So think of pneumatic system as an electrical board, right? Where wiring could be same as plumbing, as we call it on pneumatic system, right? So to do that, you have to know where everything would go. Like go into CAD, see, let's say where you guys know where you guys would know where the compressor would mount, where the manifolds would mount, where the air tanks would mount. Yeah, and just make sure you guys do it carefully and slowly, so you guys, nothing goes wrong. For example, an air explosion.
That's not too likely. But
Yeah,
could happen. All right, and so just some tips because setting up pneumatics can be tricky. There's a lot of things where if you don't get it like just right, it can be a real pain to deal with. So when you're cutting tubing, so this is the tubing right here. You want to make sure and cut it straight, a nice 90-degree angle right there, because if you have any bits sticking out, that could cause a leak. And leaks in pneumatics are your worst nightmare. They're not fun to debug. Luckily, when I set this up, there was only one leak, and I fixed it. And yeah, but usually, especially if this is like your first time setting up pneumatics, you're going to be springing leaks and stuff and fixing them. So it's good to be on top of your game when you're doing that. So you want to properly use Teflon tape. So Teflon tape is basically this this tape that comes in a roll. It's kind of weird. It's kind of stretchy. You basically roll it onto the threads of, yeah, I don't know if you could see, but like you can see like this white tape in between the joints, the fittings. You basically wind that around the threads on the fittings so that when you put the fittings together, it makes sure to have an airtight seal. And so you want to wrap along the threads when you're doing that, so that when you twist it in, it doesn't undo itself. Also, using different color tubing for better organization. It's really useful when you're for the tubing when you have it going to cylinders, right? You could say, okay, black's always going to be, you know, the extension tube or whatever, and then red's always going to be the retraction tube, something like that. For the storage system up here, it doesn't matter too much because it's all kind of just going together. But up here, it does kind of really make a difference. All right, and so we've added some helpful links which we can send out to you guys. That's basically just going over like the pneumatics rules. They lay them out pretty clearly. The pneumatics manual and some free Bimba cylinders that you can get from First. Yeah, so I think we can demonstrate this system right now. Do you want to turn it on? Yeah, so that's the compressor. It's pretty loud. Another, yeah, is it still on? Huh?
Yeah.
Oh, okay, we are at 120 psi. All right.
So stable it. No, new with you.
Yeah, and then hit A on the button. Okay, should work.
It says it's enabled.
Yeah, there you go. So that's
so delayed.
That's actually way above regulated pressure. I didn't check that before, but yeah, you would generally crank this down to 60 psi. And I can actually, okay, so yeah, another good thing is if you're debugging and you don't have your, let's say you don't want to set up your driver station or whatever, you just want to see the actuated motion. There are two buttons generally on your solenoids which are like the manual switches, right? So let's say, yeah. I want to see how many times I can. Okay, no, I think I'm gonna wait for him to like get into some other thing, and then I'll scare him.
That's been forever.
But basically, there's a point at which when the PSI falls below a certain point, your compressor will turn back on and fill those tanks right back up. And with that, I guess, do you guys have any questions?
Do you guys usually opt, so like you said that the off-board compressor is an ideal situation because you don't have to worry about the weight of the compressor or like the current that it's running.
Yeah.
But do you guys usually opt for an onboard compressor because of, you know, like shifting gearboxes and other things like that where you need a lot of pneumatic cycles per match? Or do you usually charge it off for it?
We'll do it so that we don't need to think about it.
Okay.
I mean, as long as we have the space and the weight, but if we get to a point where it's like crunched, like on our 2016 robot, it was a really small robot, it was only 22 inches by 24 inches. We found one place that it just wedged in. If we didn't have that one little crevice to put it, we probably would have figured out a way to go without it. But it is nicer to have it on board. You don't need to deal with the extra layer of inspection and stuff like that comes with it. There's also, like, just historically been a lot of issues in the past where teams that have an off-board compressor will fill their robot with air from whatever, you know, a big storage, like shop compressor or whatever, and it's technically against the rules. And so now it's just a controversial thing. So
Yeah.
leave it on the robot, there's no questions asked.
I guess it's all scenario based. Like if you can't really play along with too much weight, like you're kind of towards the end of like your weight limit, but you have the space, then like just put extra like air tanks on there. But if it's the opposite, you don't have much room, but you can you have weight to play with, just put the compressor on there. Obviously, there's more to it than that, but that's like I guess just two basic choices.
It's also just the fear if you have used pneumatics where if you put the robot on the field, you have like some slow leak, and you're just sitting there and I mean, I know it because I lived it, but you're just sitting there counting the seconds go by, going, oh my God, are we going to have enough air to get through the match? Are we going to have enough air to get through the match? And it's like, all right, we'll we'll be fine as long as the compressor's on the robot. And also building a not leaky system too, which is like the ideal start point.
It's always a bit more reassuring to have it on the system.
Yeah.
Yeah. So I know, because we didn't have a compressor on the robot last year, but so my experience using pneumatics, like when I was a student, was we always like wanted a compressor on there, you know, just in case, like, and so it wasn't an extra thing to worry about, basically. But yeah. Right.
One way first, but how do you go about debugging the pneumatic system for leaks?
Okay, leaks. So you want to basically, you can do two different things. So what I do is usually you want to feel for the air, right? You like grab a component, wiggle it around, like see, is this wiggling make it feel like you have more air coming out? You can also hear there's like a slow hiss or whatever. Bigger leaks are obviously easier to find than smaller leaks. It's those small leaks that like you can't hear or feel anything, but you see the thing going down. Well, you don't actually see it, but like you come back like, you know, 2 minutes later and it's already like, you know, a quarter of the way down.
The best tool is soap and water.
There's
Mix
what?
soap and water together.
Yeah.
Just drip it
Yeah.
on each connection, and you'll find over time, you know, bubbles. You see bubbles coming out around a connection, then there's a leak there. So
We use a stethoscope also. Use that, take the end off, and then you can move the tube around
Yeah.
here where the leak is.
Yeah, you basically want to isolate that leak and then figure out if you need to like recut the end of the tube or if you have to, if like it's a faulty component or something. Because I've had like these like pressure valves, I've had like some of them crack before. Those are not fun. But yeah, you want to like figure out, like isolate the problem using, you know, those various techniques, and then, you know, just figure out what's wrong and then replace it or redo it.
it helps a lot too. I don't know if you guys have experienced this before, but we've had, you know, tubes like burst because it happens a lot when we get to the summer, because it starts getting hot and humid, especially in New England, and like, you know, school gyms, not air conditioned or whatever, and we'll actually have tubes start blowing out of
The weekend.
the snap valves. Yeah, the quick fittings, and so sometimes it'll happen. You know, we're storing our tubing up, you know, rails and stuff like that. It'll get nicked and stuff like that over time. So we're pretty, you know, steadfast in that, like red and black tubing routing, and then labeling those tubes. So we know for every piston, you'll label a set of tubes. You know, they'll be wrapped together as like number 1, and then we know that red would be return and black would be you know, forward. And so it's just like electrical wiring. You know, you can test, and knowing which tube goes where on each end lets you diagnose where the leak is coming from, what you have to do. So we've had to go in and rip, you know, 5-foot section of tube out of a rail or whatever because it got nicked when someone was drilling a rivet out, or the tube, you know, was slipping out because of the moisture and humidity in the air and stuff like that. So.
Yeah, there was one time, it was like my senior year of high school. We had a off-season competition in Houston, and for those of you who don't know, Houston gets really, really humid. Like, I want to say in the summer, but it's always humid. But so we rolled the cart outside because we had to go like from one building to another to get to a match. And that time when we were outside, there was like a lot of water just from the humidity got into our system, and it just like screwed a lot of stuff up. So you want to make sure and like keep it closed if you're ever in a humid environment. Yeah, that was not fun. But what's up?
Is there any like case where you see a team not use pneumatics, but their robot would be like exponentially better if they had, or not exponentially better, but just like significantly
The
better?
biggest one I see is always, it's like intake systems. And it's like most teams will figure out how to suck a gear in or suck a ball in, but then they'll mess up on the actual actuation of it. Like arm joints and like single pivot joints that aren't, you know, continuously rotating are really hard to do. You need the limit switches and the intelligence on both ends. They need to be properly geared so they're not going at, you know, 1 million miles an hour. And pneumatics are so nice for that because it's a really predictable way to get force. Like it's in pounds of force, you know, which is like everybody can relate to that. So you know how heavy the thing is. And then you have these flow control valves that you can put on the actual piston so that you can make it slow or fast, and it's still the same amount of force, it's just, slowing the thing down. You can just tune that right then on the fly. So that's the biggest one I see. Is like, I saw it like all the time this past year, teams with trying to place the gear on the peg, and they're doing it with a motor controller or like a joystick, trying to like manually like guide it down and on. And it was just like painful to watch because it'd either be like too slow or they whip it down too fast. It was just like clearly they had no control over this motion. And it's like if they had pneumatics on there, we could have, if they were a partner regardless, if we saw that happening, like flow control valve on it, like you guys are good, and you're set for the. So that's a big one I see. Just anything that's two position, we don't need an intermediate spot, and people trying to do that with the motor.
There is a way that you could set up an intermediate spot on a piston as well. Okay, there are magnetic reed switches, magnetic switches that you can mount to the side of your piston, and through software, as the piston itself passes through the cylinder and picks up on that reed switch, it's a magnetic switch. It'll stop it right there by applying the same amount of air pressure on the back side of that piston, so it'll stop it.
Hold it right in place.
And then you hit it. Then in software, okay, then you can override that. 3 years ago, in Big Red Ball, they had to throw over the top. On my own team, on Rosie, we used that for our shooter. We had surgical tubing. Okay, we threw back our piston, held it right here at the bottom, and fully almost loaded. And then our mechanism to release that, we had to pull that piston back another 3 inches into a cone and bearing situation, and then release the fingers. So there is a way that it's not just two position, but using one of these magnetic switches, you can add one or two intermediate placements as well. The other thing one thing I want to mention, I'm putting on my inspector's hat. Pneumatics is a great way to implement, is a great system to use to implement a number of things. But it's also one of the most complex systems to inspect. Okay, there's very specific rules in the robot manual that you have to abide by. Okay, the pressure, the 120 psi storage, the 60 psi working pressure, calibration of your blowout valve. Okay, the diameter of the tubing that you use. Okay, there's very specific rules that are in place that person puts there for safety, and it's one of the biggest areas in which we find infractions because people they want to get that little bit of an edge. Okay, they want their pistons, they want their cylinders to work quicker than anybody else's. Well, that's one of the things that the inspectors, you'll see them on the side of the field that they're looking for. A team that may have implemented and modified their pneumatic system to work faster, and it's one of the things that we're trying to watch. So you just got to be careful, as with the electrical system and anything else, but pneumatics especially. Most of my inspection staff has been around for 5 or 10 years, and they've built, have been on teams and have built them. But it is one of the most complex systems that you really gotta watch what you do and read the rules, read all of them.
From a safety standpoint, then, is there specific rules that you have to use that blowout valve, that pressure switch, that regulator?
Yes.
And,
Yes.
and at least one of the larger gauges that come with the kit parts?
Yes, there's specific, yeah, it'll all be spelled out, it'll be spelled out in the manual when they're released.
The regulators have a little more flexibility, the gauges have a little more flexibility, but the safety switches, the pop-off valve, and the actual
have to be the ones
are
that are
specific part numbers.
Now also on the nascent pressure switch, the one that ties it electrically to the control system, okay? They're bought at 120 psi is what they're spec'd out at. Some of them, and we recognize that, some of them will cut off at 115 or 117. Okay, so they're not always like right on the money. Okay, just, if you have a collection of them and you need to have that extra 2 pounds, then just, trade off with one in spare parts or whatever and see if you can get it. But the, excuse me, the big thing to worry about is the size tubing, the fittings, the specific solenoid valves, because the sizing orifice in the last couple of years has been the size of the fitting. Okay, and the ID of the tubing. If you can get 1/4-inch tubing with different IDs, in other words, a thinner wall or a thicker wall. Okay, you want to make sure that it's 187,000 ID. That's the restriction on flow. Is the tubing.
So a couple of things. For, I guess, people that don't know, Dana Henry over there, who's just talking, he's the head of LRI for New England. He's the one that's going to be busting your balls about all this stuff. So listen to all the things he's saying. Secondly,
and if you make it to Worlds, I got a division at Worlds too. I'm one of the guys that writes the robot rules.
Yeah. So for anybody that's planning on experimenting with pneumatics between now and like kickoff, I would highly recommend looking back on like the inspection sheets for like just past years, because as far as pneumatics go, most of it is just copy and paste. Every once in a while, like some little thing will change depending on something that happened in the previous year. But it will like list out all the things that you can and can't do as far as like fittings and like size tubings and stuff like that, just so that you aren't really experimenting with like things that you aren't allowed to use before kickoff. Because then when you get to filters and you want to use pneumatics, you're only familiar with things that you aren't allowed to use, which isn't very helpful.
All right. Yeah. Anybody else? Is there any best way to attach the cylinders? Do you know the tanks?
Very carefully.
So the tanks, generally, so I've seen different ways people do it. Some people have like these clips that you like, they just kind of, with these plastic clips, you stick them on. You can 3D print them if you don't want to buy them. Also, a lot of people just zip tie them on, just kind of like this. Just don't have them near anything that could puncture them or anything like that. They do take up a lot of space, so you want them somewhere where like they can fit, right? But yeah, it's not too hard to really mount them. Like zip ties will work; it'll do the trick.
The big thing to remember about pneumatics and mounting these tanks, number one rule: pneumatics have to remain pristine. In other words, you can't paint them, you can't modify them. You can put a small label on a tank or a piston to label, tank number 1, tank number 2. We'll allow that, but as far as painting them or making them pretty or whatever, that's not allowed. They need to remain pristine. The plastic storage tanks, the best way, the easiest way is to use the clips that are available. I think you guys got a couple of clips on there. That are available through Andy Mark or in the kit, actually. That's one way of doing it. If you don't want to use those because of space considerations, you want to just zip tie it to the side of your frame piece, that's fine. But I would suggest that you put a piece of neoprene or some sort of a shock-absorbing material on the frame piece, then mount the tank to it, and zip tie the tank to it. Okay, don't stick the adhesive back neoprene to the tank, because that glue, that adhesive will over time will degrade the plastic of the tank. We'll end up with, we actually had the Army Corps of Engineers down in Louisiana in the testing lab that they have down there from one of our other divisional LRIs, did a lot of burst testing on tanks a couple of years ago. And you'd be amazed at how easy these things will go. So remain pristine on any of your pneumatic components, and also and be aware of how you're mounting them so that you're not you're inducing any shock loads or any sharp edges or anything coming in contact with those tanks. Even to the point where Andy Baker painted all of his tanks purple one year, and we made him change it out at championships. Now, do you know who Andy Baker is? Andy of Andy Mike. So yeah, he never lived that one down.
Yeah, don't paint your tips. They come in black, so they'll work with anything. Anybody else? All right, well, if you guys want to come up and look at this again or want to come up and ask more questions, feel free to do so. Thank you guys for your time. I hope you guys learned a couple things. Yep.
Yeah, we're like 15 minutes to the next presentation, so feel free, you guys can ask these guys any questions or any of us. And,
So one thing you guys didn't talk about was flow regulators. You mentioned it, but you didn't talk too much about it on the pistons themselves.
Yeah.
It's another part of the system.
Yeah, so we don't actually have any flow regulators on here, just the pressure regulators.
they're not required.
No, I know they're not, but just in terms of why you use them.
Yeah. It basically, like Brando said, it basically, you can change the speed at which, something goes. If you want, like, let's say your intake to drop down, like,
Yeah, you're restricting the airflow with it.
yeah, so you're restricting the airflow.
You restrict each direction, which is the important part. Right. They're one way, so you can make one way fast and the other way slow, which we use all the time.
Yeah.
It's just in the fitting itself is a little needle valve.
Yeah.
And then there's also a lock nut on the needle valve, so you can you go down halfway or
position,
wherever
lock
you
it.
want, and then you can the hand right in the water. They work very well.
So people are more than welcome to come up and take a look at this. if they want.
Let me see if it's legal first.
Better put the pressure down. It's working.
Here comes Hector. There are a couple things I have to do with the electronics. I couldn't find the thing that was screwed onto there, so I cut a PWM connector.
Hector's defining is his setup.
So it wants to blow out at 120?
Actually, well, I have to check, but I didn't see
You know how to do that?
Yeah.
You know how to test it?
And do it. Yeah, we probably shouldn't have people around.
Yeah.
Yeah, sure. Yeah, you guys get scared too, right?
Does the blowout valve only blow out once, or is it?
No, it's this guy right here. And once he gets it, okay, so this is a lock nut. So you loosen that, and then it's nothing more than a spring. Loosening up this cap. Loosening up this cap. So what you want to do is you jump these out. It'll go over one. Which it is now. Okay. And then just hold your finger over. With your finger and then start going off. Or not. Yeah. That looks like a legal system. You guys want to take pictures of it? Go ahead.
Alright, you wanna like make it not dangerous?
Just don't. Actually, as long as you're not within the range of the actuators.
Yeah, sure.
So now we actually okay, this roller.
It just goes out and like it turns the system on, keep pressure, and put it back in.
I can manage it.
A lot of people do that.
What comes in that?
So I believe you get the compressor, you get the switch, swap valve, the gauge, some tanks. You get maybe, I think you get 3 cylinders.
Oh yeah, you can actually. So
on YouTube.
I don't know the specifics of it. So
This is, yeah, so
check it out.
everything upstream of this regulator is stored. Right? You can think of stored as anything that goes along with the tanks, right? So yeah, this tells you that we're currently at 120. This is actually, I think this thing is on because, let me turn it down. I kind of just grabbed a bunch of random parts and put them out.
Oh, I'm just gonna be passing around.
And then these actually.
Will that work?
So there's streaming. Oh yeah. I think you can buy two device like there's also there's like other places where you can buy the tubing and like different colors and stuff. You can get it there. You just have to make sure that it's like a 1/4 inch ID and then whatever ID. That should be in the manual, the regulation.
So I it basically just takes air.
So that depends.
Yeah, like,
because I've definitely worked with systems where like you'd have it working and then maybe like the next competition like has more leaks.
Yeah,
it is like it's not low, but like the better you can get it locked down, the less time the pressure is. Like if you have a lot of leaks and you don't, if you like fix them enough, but like don't actually fix them all the way, then they could essentially lead to more leaks. If you like the higher pressure you have, like let's say you're working pressure, you're at 60 all the time, that's gonna probably lead to more potential leaks. Like let's say if you're at 40, and like you only need it 40, right? So you should try to go as low as you can. So, but obviously not lower than what's required.
awesome.
Pounds of force. So this is, that's a great question. So this theoretically would be at 60 psi. Right now, this actually is but so let's say we're at 60. It could be lower, but let's say we're at 60. This is I believe this is a 3/4 inch or maybe an inch. Let's say it's a 3/4 inch. You can take so 3/4 squared times 5 is the cross-sectional area times the stroke. This is like 6 inches, so 6 inches times 3/8 squared times pi.